So this is C3, Chapter 1, Successive Transformations. We started this ever so briefly at the end of last lesson. We're having a sort of start graph at the moment for everything we're doing of y equals x squared. It just looks like that. So our function of x, f of x, equals x squared. Okay. Yes, I do have a ruler, Corey. So it's actually having spotted one. So, okay, first one we looked at was y equals x plus 1 all squared. So what has happened here is, what was in the bracket here was an x, what's in the bracket here is an x plus 1. We said last time that that is a shift left of 1 unit. So f of x plus 1 is a shift left of 1 unit. That's as far as we got last time. That was graph 1. So next one, graph 2 is going to be what happens if we have y equals 3x squared. Well, that x squared is f of x, so what I'm doing now is writing a 3 in front of it. Okay, this shouldn't be new at the moment, this is just a recap from previous units. The new bit is when we come to put this together later on. So, can anybody tell me what will happen here if I stick a 3 in front of my function?
It enlarge.
It will enlarge. Can you give me some more detail on that?
Like that way.
Like that way, okay. For the benefit of the video, you were going upwards. Okay, an enlargement upwards. So is it actually an enlargement? Because an enlargement, if you do something upwards, you also need to do the same thing sideways. So is it an enlargement, or should you be thinking of a different word that Corey's just said? Stretch. So yeah, it's a stretch, okay? It's a stretch. If it's a stretch, we need some more information. What information do we need? With a scale factor of 3. In which direction? You said vertically. Okay, well that's what you do with your hands. So yes, it's a stretch of scale factor 3 vertically. So what will happen here is... Has anybody got a red pen? I'm missing my red pen today. That felt would be great, thank you very much. Prepared person. Just for the benefit of everyone. Look at Laura's pencil case, how organised that is. So I'll take that red pen out, thank you very much. So, what's going to happen now is, instead of being that, it's going to be, everything is actually going to be stretched. So here, where I was that high before at that point, I'm now going to be 3 times that high at that point. So it's actually going to look much, much steeper. So whereas before, on this one here, that would have been the coordinate 2 what? On y equals x squared, that would have been 2, 4, yeah, okay. On this one here, if the x value is 2, the y value now will be 12, yeah, 3 times as high, okay. So what's happened here is it's been stretched that way by a scale factor of 3. So you can either say it's been stretched vertically, or the other thing they sometimes like you saying, rather than vertically, you can say it's been stretched parallel to the y-axis. That's the direction of its stretch. It's been stretched scale factor 3 parallel to the y-axis. We all okay with that one? Graph number 3. Okay, well that's graph number 2, sorry. Graph number 3 coming up. We will do x minus 5 squared. What will happen with this one? X minus 5 all squared. That is f of x minus 5.
We'll move 5 to the right.
Yeah, that one will move 5 to the right. That's correct, okay? So, the normal x squared graph, but it's shifted 5 to the right. So that's now at 5. Where will this point that used to be 2 along, where will that be now? That point there will be 7 what on this one? All we've done is we've shifted the x squared graph 5 right.
2.
It would have been 2 along, so it's shifted 7 along.
4.
7, 4, yeah, that's right. Okay, so that's that one. That one has just gone 5 right. Right, next one then. Number 4. Y equals x squared over 2. Another way of writing that down is y is a half x squared. Or y equals a half of our original function. All the same. What will happen here? It's very much like one we've done already.
To be stretched in the x direction.
It'll be a stretch. Just with your hands, do which direction you mean.
So it's like that would go right.
In the y direction.
Yeah, it's just like this one we had here. Because I've just stuck a number in front of the f of x in front of the function. So it will be a stretch of scale factor a half.
You call it a stretch, or is it like
You still call it a stretch even though it's been made smaller. Okay? So yeah, this is a stretch. Scale factor a half vertically, or the proper way to say that is parallel to the y-axis. So this time it will still go through the origin, but at 2 across, whereas y equals x squared took us to 4, this will only take us to half of 4, so it'll take us to 2. So here that will be the point 2, 2. So if one way of thinking of it, which is what I do in diagrammatical arrows, you sort of pushed it in vertically. Everything is a sort of a half away from the x-axis, half the distance it was away from the x-axis. Okay, all happy with that one? Okay, so next one, number 5. Y equals x squared plus 4. Sort that focusing out if I can. Okay, that is my original function with a 4 stuck on the end.
4 up?
4 up. Okay, yeah, so you can say 4 up. If I was doing it with my year 9, I'd say 4 up, that's great. If I was doing it with my year 13. So, what's the proper wording we should be using here?
4 in the y direction.
But even before that, before you say translation, first of all, yeah, translation. And how should you describe translations? Using vectors, yes. So it's a translation of, and what is the vector for 4 up?
0.
Yeah, none along, 4 up. Okay, so that's the proper way you need to describe that at A level. So it's your original curve, it's just been shifted up 4. So that has just taken it up 4 in one way, just a one-way shift, slide, a translation. Right, next one, number 6. Y equals mod of x squared. So that is y equals our original function with mod signs around it. What will that do? Can you think about how you could sort of write that down in words or express that in words, what that would do to any function?
Make it all positive.
Say it, Billy?
Make it all positive.
Make it all positive, yeah. If any of it was below the x-axis, if any of it was negative, it would be made positive. Yeah, the our x squared one started off life like that, where none of it was positive. Sorry, I'll say that again, when none of it was negative. So we'll have no impact at all on this one. So that is y equals x squared. It's also y equals mod of x squared, because nothing was negative to start with. However, if I had started with something different, now this is where we sort of get to the combining bits. If I had started with x squared minus 2 and then modded it, first off, what is y equals x squared minus 2 going to look like? Yeah, that's a translation of 2 down, so a translation of 0 minus 2. So mod of that, what will that look like? Mod of that, anything that was negative will be made positive. Corey's doing the right thing. That was positive before, that was positive before, that's not changed. What was negative down here gets reflected up in the x-axis, so you get that. So that one on the right is y equals mod of x squared minus 2. Anything that was negative gets reflected in the x-axis. That's the key thing there. So anything where y is less than 0, in other words, where y was negative, where the graph is negative, gets reflected in the x-axis. Okay. We all okay with that one? Right, I'm going to stop the video there because that's a 10-minute clip and start